So here in this problem, we need to check whether if 3 points whose position vector given to us are collinear or not. Okay, let us begin. So what we'll do, we'll first consider 3 points. Let's say these 3 points are point P, point Q, and point R. And we're also going to consider another point, which is going to be the origin of some coordinate system. Now, we will define the position vector point P, Q, and R with respect to the origin. All you have to do is join the origin with the respective points with the help of a directed line segment. So now we begin by defining the position vector of point P. So let's say the position vector point P, which is defined by the vector OP. Let's say this is denoted by I cap plus 2 J cap plus 3 K cap, where I cap, J cap, and K cap are unit vectors along X, Y, and Z direction. Then we will consider OQ vector to be the position vector of point Q, and let's say this is given by the vector 3 I cap plus 4 J cap plus 7 K cap. And then we have OR vector. We will consider OR to be the position vector of point R. It's a vector denoted by negative 3 I cap minus 2 J cap minus 5 K cap. Now what we'll do, we will join point P and Q with the help of a vector going from P to Q. And let's try to find out the vector PQ. So vector PQ is simply defined by taking the position vector of the endpoint, which is Q, and from it subtract the position vector of the initial point, so that's P. That means OQ vector minus OP vector is given by the vector PQ. So what is OQ vector here? OQ vector is 3 I cap plus 4 J cap plus 7 K cap. From here, we are subtracting OP vector. So that's negative I cap, negative 2 J cap, minus 3 K cap. That will be equals to, now 3 I cap minus I cap, that's 2 I cap. 4 J cap minus 2 J cap, that's positive 2 J cap. 7 K cap minus 3 K cap, that's 4 K cap. We're going to label this as number 1. Next, what we'll do, we'll join Q and R with the help of a vector going from Q to R, and also try to find out the vector QR. So vector QR is going to be OR vector minus OQ vector. So that is going to be equals to, so we have negative 3 I cap minus 2 J cap minus 5 K cap. And from here, we're going to subtract OQ vector. The OQ vector means we have negative of 3 I cap plus 4 J cap plus 7 K cap. Fine. So let's find out this value. So negative 3 I cap, negative 3 I cap, that gives us negative 6 I cap. Then we have negative 2 J cap, negative 4 J cap, so that's going to be negative 6 J cap. Then we have negative 5 K cap, negative 7 K cap, so that's going to be negative 12 K cap. So this is our vector QR. However, we see here that QR vector can be also expressed as, if we take, let's say, negative 3 as the common vector, then we have negative 3 multiplied to 2 I cap plus 2 J cap plus 4 K cap. Fine. Now what is 2 I cap plus 2 J cap plus 4 K cap? This is the vector PQ. We have already defined in equation number 1. That this implies that QR vector equals to negative 3 times the vector PQ. And whenever this particular criteria is met, that means QR vector can be expressed in terms of PQ vector. All we have to do is multiply it with some scalar, which is negative 3 in this case. This simply tells us that the point P, Q, and R, these 3 points are collinear. Only then we can express the vector QR as a scalar multiple of the vector PQ. So we have successfully verified that the 3 points whose position vector given to us are indeed collinear.